And no matter which external fixator you pick up, it's called a ring fixator also, right? So no matter which one you pick up, it's based off of two things. It's based off a ring, right, and a wire. Okay, so first the wire, right? So the wire is the thing that interfaces the body to the fixator, okay? Now there's different kinds of wires, but when you look at wires, there's two common wires. All right, there's a smooth wire, which is exactly that, it's a smooth wire, okay? And then there's an olive wire. Olive wire, why is it called an olive wire? Because it has this little expansion in it right here, okay? Every wire, when it's an olive wire, is marked on the side of the olive with laser etchings. You see all that? That way you always know what side the wire is, or what side the olive's on, because when the olive's buried under the skin, you can't tell, okay? So you have to know where it is. All right, that's just the olives. Now, the olives usually come in 1.8 millimeters diameter, and I think Strikers, some of theirs are 2 millimeter. Like this one feels like 2 millimeter, right? 2 millimeter diameter. See that? And this one feels like.
They're three sizes.
This is a 1.8. It's a little bit different. So if you feel enough wires, you'll know the difference. All right. Anyway. There used to be pediatric sets that they sold that had 1.5 millimeter wires, diameter wires, but they don't make those anymore. Most wires come in approximately 300 millimeter length, all right? But companies do different things, but mostly every company sticks with the same size. The pediatric ones used to be shorter, but you know, they're not really used anymore, okay? So you have your wire. They're all made out of stainless steel. None of them are made out of titanium or anything like that, because it has to be able to stretch, okay? We'll talk about that in a minute. Titanium doesn't stretch. All right, so you got the butt end of the wire, which is usually flat. All right, we'll talk about that in a second. And then you got the front tip. The front tip is made a number of different ways. All right, so there's something called the bayonet tip, which is the most common tip. All right, it looks like a bayonet. You guys will pass this around later. Okay, it looks like a little bayonet, rounded on one side and flat and sharp on the other side. Okay, and it makes it easy to drive. Striker wires also have a bayonet tip, but they're built a little bit differently. You'll pick it up, you'll look at it later, you'll see why and why not, okay? And for a while, it was popular for companies to make drill tips. Why drill tips? Because A, it's easier to get through some of the bone, all right? But it also cuts down on the amount of heat you generate when you're drilling, all right? So the drill tip would drill right in. The problem with these was, really one basic problem. The drill part of it is weak, right? So they a lot of times broke. All right, but that was a good idea. Now, the back end of the wire, flat, unless you're in another country. In Russia, where they've developed this system, the back of the wire is made very specifically. They have bayonet tips, okay, but the back of the wire actually has a slot cut into it, and there's a reason for that, all right? In America, the wire drivers are cannulated, so the wire goes straight in, right? The wire goes straight in and they're cannulated, right? In Russia, the motor is sitting on the floor with a hose, okay? Well, it's not really a hose, it turns, all right? And the wire, it's a hand piece that you hold, right? That's connected to the floor drill, and the wire just pushes into the very tip of it, all right? So when you're drilling, the wire is like this, all right? So that whole thing of holding the wire with, okay, we'll get to that in a second, all right? All right, so really those are your wires. Now this is actually a special wire. For a while in Russia in the 70s, they were trying, see this is black and the other one's is silver, right? They were trying different coatings, so they wanted to try an antibiotic coating, so this has a carbon covering over it because I guess carbon kills stuff, okay? All right, so, but they don't make them anymore, it didn't work. All right, just add a few. That was cool to save. All right, so you have your wire. And that's that. Then you have your ring, right? So rings, not that, rings, right? Rings come in full rings, right? Full rings, half rings. You're gonna notice that a lot, when they build half rings, all right, you're gonna see that they have offsets. You see how it's offset, just like that? And there's a reason for that offset, because when you add one and you made it to the other side of it, right here, the offsets are on both, and it's gonna keep the entire plane of the ring in one, all right? That's why these are built that way. You don't need anything to put these together, but to put these together, you need something, okay? You need bolts, right? So the Elizarov systems, no matter which company it is, right? they have bolts, and bolts come in different sizes. They come in 30 millimeter, 20 millimeter, sometimes 16 millimeter, sometimes 8 millimeter, and a few other sizes. Okay, I just pulled out those two. Okay. Now, if you're going to use a bolt, you have to use a nut. All right. All right. So there you go with the nuts. All right. There are different kinds of nuts. This one's a little bit lower. This one's a little bit higher. These are all 10 millimeter nuts. All right. Now, there's another kind of nut. Okay. And that's pictured right here. And here's another one of those. All right. Again, different companies have different designs. All right. These are called high profile nuts. What else do you guys call them?
Close encounters.
Close encounters is like an old school.
Long.
Right? And the reason we use those is if you have a nut right here, okay, so I put a bolt right through, all right, and I put the nut on it. Sometimes it's hard to get another nut right next to it, all right? So what you do is you put this on next to it, and it's just an elevated nut. You see that? It's called a close encounter because you're putting them next to each other, all right? And there's a few other names for them. But those are the most common ones. All right. So those are also called high profile nuts. Okay. All right. High profile nuts. The old Alizarov high profile nuts, on the nut side they have like little dice markings. You see 1, 2, 3, 4, and that was originally made. These look very different, so it was easier for the doctors and the patients to see this, and they would be able to turn this, and they would know how much they're turning it. All right. Quarter turns. Okay. All right. Now, half rings. There are other kinds of rings. There are 3/4 rings. There are 3/8 rings. There are other rings that actually flare out because they're made for shoulders, so they flare out at the ends and for hips. All right, but we don't really use those. The most common rings you're going to find are full rings and half rings. Okay. Now, how do you put a half ring together? Well, take a bolt, put it through. You take your nut, put that on. And that's that. All right, that's how you make a full ring. Okay. Now, rings have to be put together. All right. So the fixator, it's a big erector set. So the fixators come with threaded rods. Threaded rods come in all sizes, and if you really need to, you can cut them, but you don't have to because they come in every single size possible. 200 millimeter rods, 100 something millimeter rods maybe, bigger rods, smaller rods. Okay. They even have highly specialized rods that allow very, very special rods that have a slit in them. Let's look at those. So those are your threaded rods. Some threaded rods have a slit. So if you look closely, past that, here, take a look at that one. These are all different sizes, but you see that? They have a slit inside them, all right? And that slit is actually very specific. It's made for a wire to sit in it. Of course, not that wire. It's made for a wire to fit right in it. Why? We'll talk about that in a little while when we start putting things together, all right? But you could actually attach the wire to the threaded rod, and then you could set up some sort of mechanism to pull or push that threaded rod, and by doing that, you're pushing and pulling the wire, all right? And then by doing that, you're pushing the wire that has an olive on it. The reason for the olives, right, are to push bone, pull bone, or to hold bone in place, all right? And actually, it's very interesting. There's a difference between a Russian wire, old school Russian wire, and a modern wire, okay? They're called olives in America. They're called welds in Russia. That's because the wires are made differently. They make the wire in America, but that olive here, that's actually part of this metal. It's a chunk of metal, and they put it on a lathe or whatever it is, and they cut it out. So that's actually part of it. In Russia, that's welded on. So I could take a hammer and knock it and make this move, all right? But that's why this isn't allowed here, okay? But that's how it is over there, okay? Those are wires, those are rings. Then you have the threaded rods that hold rings together. Now rings have to come in a number of sizes. I mean, this is a pretty small ring, and every ring is always marked, right? So this one over here is marked 180 millimeter in diameter. This one is marked 120 in diameter, okay? We'll talk about how you choose a ring when we start putting it on, all right? How do you know which ring to use? Well, generally when people are first starting, the ring is equidistant on all sides, and usually it's 2 finger breadths, okay? So you want to ring 2 finger breadths all the way around. So for an arm, this might be good. For a leg, this is probably not so good unless it's a club shape and you use it. As you get more proficient with X-Fix, you know what part of the body swells more and what swells less and in what condition. So maybe in this case, I know the back of the leg, let's say, swells more. I'll put the front closer. The bottom line is you want these rings as small as possible, not to be dangerous. Dangerous meaning if the person swells up, they could swell up against it, all right? The smaller the ring, the better the wire attaches to it, okay? Now, wire attachments. You took the wire, you put the wire through the bone, all right, and then you're gonna attach a ring to it. Now, when you put a wire through a bone, you're putting a wire right here because it has to be here. You know, wires are put where they have to be. Now again, in a tibia, let's say, you could put it here, you could put it here, you could put it here maybe, okay? But in certain areas, you know, maybe I need it right there, just above the, you know, just in the metaphysis or something like that, all right? So these wires are put exactly where they need to be. And then the rings are put on, okay? You always capture the wire where it lies. So in other words, if it's through the bone and it's sitting up here and you need your ring down here, you don't pull your wire down to the ring. You have to build up to the wire, okay? Now, how do you attach a wire to a ring? Well, you use, it's like a little hand, right? And these little hands are called wire fixation bolts, all right? And they're little hands that hold the wire down to the ring. Now, there are all kinds of wire fixation bolts. But when you break it down, the most common ones are 2. There's one that has a slot, okay? That's called a slotted wire fixation bolt. And it's a slot that captures the wire, okay? And then there's others called cannulated wire fixation bolt, where the wire goes through the cannula and then you tighten it down, all right? Certain applications you need this, where maybe you don't want it to slip out. Certain ones you don't need that, okay? So there are reasons for this, there are reasons for the other one, and then there are different shapes. So this one, you can see it's almost like oblong a little bit, and this is an old school one. So right now they call these Russian bolts, all right, because that's how the Russians made them, all right, because why make extra stuff? Well, the reason they made extra oblong wire fixation bolts is because, well, it'll hold more of the wire, okay? That's why, okay? But why is a Russian original one easier? It's because when you have them on a ring, and I have to come in there with one of these, this one I can grab anywhere. This one I have to actually just grab it in a certain spot, okay? So anyway, now, more recently, companies have come around and said, oh, wait a second, why don't we just put those 2 things together, right? Why don't we just put that together and make a wire fixation bolt that has both a slot for the wire and a cannula if you want to use it, okay? So some companies have that. Everybody has something different, okay? That covers pretty much the wire fixation bolts. Now, there are some different kinds, right? Like this one right here. This is a little weird, all right? Well, this is a wire fixation bolt, but you see the big hole? That's to capture a big pin. A pin, not a threaded rod, but a pin, all right? So like a Steinman pin or a, okay? Now that's that. All right, so you have your wire fixation bolt. Yeah, or, see that? But we'll get to that in a little while, these, okay? Wire fixation bolts. Okay, wire fixation bolts aside. Now, remember what I said. sometimes, if you're lucky and if you plan properly, right, the wire will sit either right next to or very close to the ring. And then you can just go ahead and you could put these little hands that hold the wire down onto the ring, all right? But sometimes the wires may be lopsided or maybe up high like here, all right? So they thought of that. They thought of these. These are posts, okay? This is a 4-hole post. This is a 3-hole post. 2-hole posts, you get the picture? Now, classically, 1-hole posts, all right, are made differently. There's something that looks like that, and then there's something that looks like that. Look close. One is higher than the other. So we might say, well, wait, why are there 2 heights of 1-hole posts? That's because the actual 1-hole post, right, is only the short one.
You are in the meeting now.
That's pretty scary.
Is something on?
Some real Big Brother stuff.
All right. Look, the high one is actually called the hinge. All right. And the reason the high one's called the hinge and not the low one is for this reason. Is for this reason. Look, if I want to make a hinge, okay, I'll take the high one and I'll put a bolt through it and I'll put a nut on it. Okay, and then you'll have a movable hinge. Now look, the hinge goes all the way to there. If I do the same thing with the lower ones, okay, it won't hinge as much. That's what you need, a little more length. Anyway, so that's the hinge. So 1-hole, 2-hole, 3-hole, 4-hole, and 4-hole. And that's all they make, all right, height-wise, okay? Now, yeah, there are other ways to capture a wire that's sitting, let's say there's a wire all the way up here, all right? Now, again, this is not usually in sets, but there are things like this, right? Like this. Now, there's a lot of different uses for these. Now, these are so important, and companies don't usually have them, that when I go to surgery for a complicated case, I bring my own little box filled with things that I might need, all right? See that? Different sizes also. Everything comes in different sizes, okay? Now, not only do things come in different sizes, but most things in this system are made in 2 configurations, male and female, all right? So we saw these posts, right? These are male posts. You get the picture, all right? Now, take a look. Here's a hinge male, here's a hinge female, okay? Here's a 4-hole female. Here's a 3-hole female. Here's a 2-hole female. Here's a 1-hole female. Get the picture? Everything's male and female. Well, okay, what does that mean? Well, male, how do you attach a male? Well, you put that on there and you put a nut on the other side. How do you attach a female to this? Well, you take a bolt, right? You take the female and you get it? Why are female ones important? Because sometimes you have to reach up even higher. So let's say a 4-hole isn't enough for whatever reason, okay? Well, what do? There's a way to attach female components to threaded rods. The way you do it is you don't just put it on, because then it still spins, right? So the way you do that is, first you take a nut, you put the nut on the threaded rod, you put the female component on the threaded rod, and then you take the nut and you push it forward up to and then you tighten them in relation to each other, and now it's tight, okay? And now look, all of a sudden I can catch a wire all the way up there. Now, that's for a whole different class. The shorter length to catch a wire, the better. because when you tension the wire, which we're going to talk about in a second, the higher it is, the more you're going to pull it. All right, so there's rules for everything. But again, people don't generally, for regular static frames that most fixators are, they don't really have to use this sort of stuff. All right, female, male. Now let's get to the actual wires. Now, if you just take a wire, if you take a wire and you attach it with 2 wire fixation bolts, one here and one here, all right, and you just tighten these down, that's really not going to help us at all, all right, because what will happen is, look how loose the wire is. The wire is very bendable, all right. So the whole thing that was Elizarov's, I guess you can call it his invention, all right, because again, external fixators were around a long time before Elizarov invented this in the 1950s. Okay, there were different kinds, and they were made, a lot of the times they were made very specific. Like there was a specific fixator for a patellar fracture. There was a specific fixator for a clavicular fracture. And Elizarov came up with a system where you could open the box and you could work on any part of the body with just what you have. You could build anything you want. All right, that's the whole point. So, how do you use this? Another wire fixation bolt. Okay, another wire fixation bolt. Now, anytime you're using carbon fiber rings, there has to be something else. See, when you tighten this down, and when you tighten this down to hold the wire, it's so much force that it literally pushes the metal down. So if you look, I've already put wires on this. You could see there's a little line. You see that? There's a little line. This metal actually pushes into this metal, okay? And you can see that, and it opens up a space, right? So you can imagine carbon fiber is very soft. So if you tighten down on carbon fiber, you would really dent the carbon fiber. So if you look at Stryker's wire fixation bolts, or any fixation bolt where somebody's using a carbon fiber ring, there's a built-in washer. See that? That's why they have a built-in washer there. So when you put this down on here and you put the wire in, you're sandwiching the wire between the washer and that little hand. Hand is the wire fixation bolt, right? So throw me some nuts,
Yep.
please. And a wire, one of your nice wire fixation bolts. Okay. So I'm going to put the wire in.
These are the real nice
I'm going to
ones.
tighten it on one side. So remember, I put the wire through the bone, right? Now I put that there. Right? I'm going to put their wire fixation bolts on. I'm going to center it where I want it. I'm going to put them down, and then I'm only going to tighten one side. When you're tightening wire fixation bolts, wait, hold on. Let me go through the really basic stuff, and then that's yours. That's mine. That's mine. Hold on.
I got
Just
you.
leave it.
Yeah,
Yeah.
these 4 were mine.
Okay. All right, you put one on here and one on the bottom, right? But this one, you don't turn. This one that has this on that side, you don't want to turn it because look what it does to the wire. It turns the wire. Now, there are reasons to do that also, but not for this conversation, okay? So you put that on there, and then you tighten this down, just this side. You hold this perfectly straight. Now, Stryker actually came up with something very specific for this. You don't necessarily have to use this. They have like this little contraption, because they have a little hole in their wire fixation bolt where you could put this in and you could hold it that way, okay? You can just hold it that way. Okay, I tightened one side, I did not tighten the other side, all right? Now I'm gonna tension the wire. So there's ways to tension wires, because what you need to do, it's like spokes on a bicycle. They're very tight, okay? Now, if you listen to it now, that's loose. And it trampolines. Okay, that's what that is. Now, companies then have wire tensioners. All a wire tensioner is a contraption that you put onto the wire, you start turning it. The first few turns, close the contraption onto the wire, grab the wire, and then the next turns, pull the wire. So you can imagine, I didn't tighten it here, I only tightened it on this side. When I pull the wire, I'm gonna pull it from here to this instrument. So let's put on one of their instruments, okay? Now they're all different. See, this one kind of goes in like this and also uses that hole, right? This has to be up against it, okay, to work properly, all right? Now, and this one, this is a little bit older, right? It goes in. I think I had a problem with this one before.
WD-40.
No, you know what? I wonder if it's because you have a 2mm wire. No, this one needs to be fixed. Okay. So you put it on, and then you hold it right up against, flush up against whatever it's flush up against, and then you start turning. Now look. Oh, still not tight. Let's see, I'll give it another half a turn. Oh, it grabbed the wire. So that it grabbed the wire. And now I'm gonna keep turning. So let's go ahead. And now it's starting to pull, I can feel it. Listen. Okay. We'll go a little tighter, let's listen. Go a little tighter. Okay. A lot tighter, okay? So this one will go to like 130, all right? A full ring you can do that to. Now, if you look very closely, again, this is probably for another conversation, at some point, rings could get deformed. Because since you're tightening it on one side, the ring could rocker, okay? So a lot of times it's good practice to put, if you're putting one wire on top, you put one on the bottom, okay? It's also good practice not to build up too high, because if you can imagine, remember what I said, the higher you build up, the stronger the leverage is. When you do this up on a wire up here, you could really bend the ring. You could probably break these rings. You won't break a metal one, okay? So now, you've tightened it, but the tightness is captured between that and this. But we want to take this off, so what do? Well, you tighten this down on this side. Okay, and now you loosen it. Take this off. And the tension is captured between the two wire fixation bolts. Okay? And then you either, sometimes you could bend it to break it, but generally we cut it. I leave a little bit of length, and then you have a plier.
But we don't, but we have this thing on the anteater right here. On the back side, you can show it down there and bend it up, but I don't have an actual
All right,
like,
so I'll just use
plier.
this. People who know how to do this know how to bend the wire. All right, so what you do is, it doesn't matter if you go up or down, okay? You go, make 90-degree bend, and then you grab it a little bit closer, and you make another 90-degree bend, okay? And you don't have to do that, but that's how you bend these wires in, all right? One and one, boom. That's almost okay, all right? I'd be embarrassed about that bend if it was me, right? So now, why the bend? Why don't you just, you know, cut it off? Now, sometimes I do, sometimes I don't. Now these you could actually break off like that, all right? Here's the problem. Well, it's not a problem, but here's why the bend. That's extra wire, even though it's bent. What happens is when these break, all right, they usually break on the inside here, along the ring or along the inside of the wire fixation bolt, okay? So if it breaks on one side or the other, what do I do in the office? Well, I loosen it. I unravel this side. Unravel it as best I can. I loosen the whole thing. Remember, it's on the patient's leg. And then I push it. I push it. Sorry about that. I push it, and just enough. See, it broke here, and I push it just enough where I could tighten it down again, and the wire's still functional. Then you might say, wait a second. What are you going to do? You don't have this, and even if you do, the wire might not be long enough to even grab it. Well, then there's another technique. There's the old technique on how to do it. all right? And I shouldn't say old, there's just another technique. You don't need a wire, like in places where they have a lot of Elizarov experience, they might not pull out a wire tensioner like this unless they have to really, really concentrate on how much they're pulling, all right? The other way to do it is called the Russian technique, all right? So let's use the same wire. Let me just try to stuff it back in here. And it's simply using two of these, all right? So somebody holds it real tight. Hold that. Not that, this. Hold one hand here, one hand here. Just be careful. Yeah, as hard as you can. So this technique's a little bit different. The wire, pretend that wire is like a rope, and pretend this little thing is like a pulley, right? So if I want to pull it, okay, let me make sure that side's tight. You make sure one side is tight. What you do is you hand tighten it, or tighten it a little, just until it's grabbing. This is a bent wire, so it might be a little weird, but we'll try it anyway. And then you put this on here, and you put this down here, and look at what you're gonna do. Well, first of all, loose, right? You're gonna tighten this down, and then you're gonna rotate both of them together. Hold it hard, right? See what happens? I'm pulling the wire. Now again, this one's bent and kind of messed up. It didn't work that well, but you get the idea. You're pulling the wire around that, okay? And that's called the Russian technique, because that's what they do over there, okay? They only pull out these when they have to move something underneath. Okay. Wires, tensioned. Now, well, you might ask yourself, well, wait a second. How do you put a wire on? How do you attach a wire to this? That's the arm. You still need a hand. Okay, that's the arm to reach up to the wire, but you still need a hand, and you would still need a wire fixation bolt from the side. Okay, but you know what? You could do other stuff with that, because you can capture a wire that's on an angle. Okay, because now this could turn in this direction. Okay. All right. Now, let's say this is too high, right? Well, we have something for that. If that's too high, we have a whole bunch of washers that you can get. Washers, lots of them, okay? Whatever millimeters, then you have ones that shape. Why is it that shape? Well, because that one's made to fit under that. Okay, all right, good idea, whatever, right? And then you might say, wait a second, this is a regular washer, it's a 2 millimeter washer. Now this one is a little bit weird, this one. This one has a slit in it. Why on earth would you make a washer with a slit? That's because occasionally you might run into a situation where you have a nut, you have a wire up here, and you have to capture it, but you don't have any other thing that you're gonna capture that wire with. What do? You make a little wire sandwich. You put one nut, then you put that weird looking slotted washer, then you put a regular washer over it, and then you put another nut over that. Now you can imagine, if I have a wire, let's use this wire right here. Look, if I have a wire, no, let's use this piece. If I have a wire sitting up here and I want to capture it, I can just put it into that slotted washer and then compress these two nuts on either side, and it's like a wire sandwich. You see that? So I can use that for something. I don't know. Maybe I can, maybe I can't. All right, and that's what you use that for. Then you might say to yourself, well, wait a second, you showed us those washers, but there's another washer here. This washer right here looks a little weird. It's got like a concavity to it on the inside. You don't have the other half to that washer, do you? I mean, you know what, I have. You don't have to. I have a letter. Here it is, I got it. And then you might find this in the set. What the heck is that? See that? It's convex. Well, that's made two, one fits into the other, and it creates one washer. And it's one washer that you can do that with, because it's like this. And that's made for if you have something that's on an angle. Is it hot in here? If you have something on an angle, you could put a nut on it and the nut will sit perfectly straight, because it's a gimbal, you know, like, anyway, but nobody uses these. Okay. Do you even have these in your set?
No, we have a hinge that's similar to it.
No. Okay.
No, not like that.
All right, so let's get rid of these. This we don't need. Now, remember what I said before about building a hinge? Let's say you're building that hinge, and you're bolt. Oh, no, it doesn't matter. You got a bolt, right? I put a bolt through, I made my hinge. You know what the problem is with a regular nut? A regular nut, right? If you want this to move, okay? If you want this to move, the problem is a regular nut, it'll let it move, but it's gonna fall off. So there are nuts that have a nylon insert, a nylon washer, all right? And what you do with those is you put that on instead. Now I'm not gonna push it all the way in, but you push it in and the nylon prevents it from moving. So you make a hinge. But you don't have to make your own hinges, okay? Or maybe you do wanna make your own hinges. Remember, we can make a hinge with two males, okay? Or we can make a hinge, let's say I need it higher, all right? Well, then I can use maybe these, all right? And I can make a hinge higher. Remember what I said, this is not the right way to do it though. First you put a nut so it doesn't rotate, all right? But look, I can make a hinge much higher. But I said, well, wait a second, you're gonna say, if I use these, look what's gonna happen. They're gonna be offset. That's why I wanna use those. But how do I use those and make them higher? Well, remember what I said before, they also come in female. So I could put that there, do it the right way, put that there. And now I made a higher hinge, right? And it's in the same plane. The hinges are made in the same plane. That's why they're made with a certain kind of shape, okay? And see, or I could put another one on here. I can make it as long as I want. Hinges. This is not for this discussion. But you don't have to make your own hinge. Now let's say this hinge is in one plane. What if I wanted the hinge to be in another plane? Well, I could take another one of these and I could put it on this way, and I could put another nut on here, right? And now I have a hinge that goes this way and this way. Very confusing. So why not make a hinge? Here's a hinge that the companies have pre-made, right? It's also uniplanar. And then there are hinges that are multiplanar, fancy, all right? And they're made in female. Why? Because you have the most use. If it's in male, that's the only height you're gonna get. But with female, you can put it on any height you want. Or if you don't want any height, you can just take a bolt, right? And you can bolt this straight onto here. All right, so those are hinges. We're not gonna talk about hinges today. All right, we got hinges, threaded rods, close encounters, other weird things. I don't know. You know, you never know. Because sometimes you want to attach two things at 90 degrees to each other. And these are called twisted plates, twisted sisters. People call them all kinds of stuff, you know. But here's one with two holes on either side. Here's one with 2 and 1. Here's 1 and 1. Generally, that's all you're going to get. All right, those are the most common sizes. There are companies where it's not twisted like that. The reason this was twisted like that is because back in the day when they made them, this was easy to make because all you need is a plate and then you twist it. Heat it up and you twist it. That's why these are made this way. It doesn't have to be this way. So there's other companies that probably have made it. Oh, here's one. This is twisted. The heck is that thing? you know? Okay, so you get the picture? There's something for everybody. Now, I use these. Hold on. No, we're not going to talk about that. That's too much. Now, so I can build anything I want. Sometimes I'll take a male and a female and put them together. For example, let's say I have a club foot that I'm fixing, right? And I want to rotate the forefoot. What do? I have put a half ring around here. Oh yeah, this is for another class. And then I'll take this. I'll build this out there. And then I'll take a male and a female. Usually I'll use the same size. Male and but it doesn't really matter. And I'll put the male into the female like that, see? And I'll leave them flexible, okay? And this is here, this is here. And remember I said I have a half ring here? I'm gonna put one threaded rod down to this side of the half ring and one threaded rod to that side of the half ring, okay? And what am I gonna do? If I shorten this, it'll pull up the medial side. If I lengthen that, it'll push down the lateral side. So you can imagine, by doing that, I could rotate the forefoot. I'll pull one up, push one down, it rotates it, okay? And the reason these two are not tied into each other is because when you're doing that, when you're rotating like that, sometimes they have to be able to move a little bit. Anyway, this is not for this conversation, okay? See? So there are, you invent things as you go. But that's actually the way to do it. Then there are plates. There are plates. Here's a 3-hole plate. There are 2-hole plates. There are 4-hole plates. There's a lot of plates. And plates are used to hold things together. There's different shaped plates. All kinds of plates. And originally, plates could be used to do things, right? It's plates, right? But there is a use for plates. Sometimes that's more common than not. Let's say somebody has a leg that goes skinny ankle and then goes up like this. You want to use a bigger ring up here and a smaller ring down here. Here's your smaller ring. And you would build out, and then build up. And you could do different sizes of things. Or maybe I need a situation where I have to do this. I don't see why I would need that. So anyway, you get the idea. Those are the basic parts. Now, the Russians only made rings. The Americans decided, and when you're using rings on a foot, all right, it becomes sometimes a little bit more tedious. Because the way you capture a foot with rings is you put one half ring around the rear foot and one half ring like this in the forefoot. And then you connect these with threaded rods. Now that's good because you could vary their relationship to each other, all right? But in a static frame, you might not need to do that, all right? So they came up with foot plates. Here's an old carbon fiber foot plate. Here's a new carbon fiber foot plate. Here's an aluminum aluminum foot plate. Here's a titanium foot plate. Okay? Different thicknesses. Okay? But you notice I didn't show you a stainless steel original Alizarov foot plate because they didn't have them. They didn't use these. Right? But anyway, foot plates. Foot, that's it. All right? U-shape, horseshoe, whatever you want to call it. Back in the day when they were first making them, they had one row, nice and sleek. Okay? Then they decided that maybe 2 rows is better for surgeons. All right. If you know what you're doing, one hole's enough. The difference though is I can move these a little bit more. These are a little bit sturdier, all right? What about thickness? If you do enough Alizarov, you need to know thicknesses. A lot thinner. I think this is, what is this, 5 millimeters? I'm not sure exactly. But this is a lot thinner because it's stainless steel. When you build something out of carbon fiber, it has to be thicker to be stronger, okay? That's because a lot of the research that's done for this stuff is with full body weight on this. So this has to be stronger for the body weight. But that's not the case. Because when you're building a Alizarov, right? When you're building a Alizarov, this isn't supposed to necessarily, depends on what the application, this isn't necessarily used to hold the body weight. This should have minimal weight going through it. This is a scaffold. Those scaffolds you see on the outside of buildings when they're working on the building, they're not holding the whole building up. They're just on the side, helping to hold it together, you know what I mean, while they're working on it. All right? Okay. Now, the Italians were the first ones to send groups to Russia to learn, probably in the 70s, I guess, because there was a famous guy named Carlo Mori who was treated in Russia for a non-union of a tibia or something, and Alizarov fixed him. The Italians tried and tried, they couldn't. And after that, this guy called, he was like a famous explorer or something like that, and he called his friends over from England, orthopedic surgeons, and they went over and they learned. Now, in Russia, at that time, they were only using wires, okay? The Italians, they came up with a system. They said, well, wait a second, why don't we use pins? Half pins, all right? Half pins, all right? So they came up with a system of half pins, okay? Again, why are half pins better? Well, they're stronger. In some applications, you want something a little bit stiffer. In other applications, you don't want to go through one side and other side out the other side, right? You only want it coming through one side. All right, and the Italians, their system was to grab these using specialized wire fixation bolts. All right, but they would still use all the original stuff. Then a guy named Stu Green, I think his name, in California, right? It was in a place called Rancho, California. He came up with a new system of, what are these called again? Posts, right? A new system of posts. Remember I said they come in 4, 3, 2, 1. Well, he came up with this, 5. 5. Here's a 3. Here's a 4. Here's a 1. There's a 1 with a male, and there's a 2. Boom. And he called these Rancho cubes, okay? Now, what on earth is going on here? Well, a Rancho cube, they're all obviously female, because the way you would fix this onto a ring is by using a bolt. So what's the point? Well, if you look closely at these, right, you're going to see that one hole is big, okay? And the other hole is threaded, all right? The reason he came up with this system is for this reason. Hold on. Find inserts.
You got it? Or you need one?
Yeah, you know, I got it. See, these pins, they come in different diameters. 4 millimeter, 5 millimeter, 6 millimeter are the most common ones, okay? Well, then you gotta make a holder for each one separately. So this guy came up with a system where you have this thing, and then you have sleeves that go in. Sleeves, ready? Here's a sleeve, here's a sleeve, here's a sleeve, here's a sleeve. Bunch of sleeves, okay? This one says 5 millimeter on it. That means a 5 millimeter pin is gonna sit perfectly in it. So this happens to be a 5 millimeter pin. I'm gonna put it in, I'm gonna drill it in, see how loose it is? But wait, I'm gonna put the sleeve in here, and then I'll put that in, and now it holds it better. And how do I actually tighten it? Well, I'll take a bolt, and I'll put the bolt in, and I'll tighten the wire. Now, they did come up with little, very, very small set screws. That's what they call them, for that reason. but people don't really like to use those because then you need a special hex key to get them out. So we just usually use short those. But look, 6 millimeter, 4 millimeter. Get it? So those are just different sleeves. So you only need one to fit any thickness of these. All right? And that's the system for those are Rancho cubes.
Can you angle those Rancho cubes, or is it just like kind of stuff where you're...
No, so the way you would angle it if you had to, let's say I have to angle a Rancho cube, I would build up on this and then do that. But Stryker has a different system. Like here's another company's system. Look at this. It's the same thing, but a different height. You know, but it's a fixed height. It's not so good. Pass me one of your holders.
Yeah.
So the Stryker system is a little bit different. Like, you know, they're all different. This is the old system. This is the original stuff.
Could you use it and just to angle it?
Well, hinges are weak. So you don't necessarily want to use a hinge, but if you had to, you would. Look, if I had to, I could, you know, I could think of something. Maybe I would do this. Well, look, maybe I would do this. I would put that on there, and since I can make this, you know, I could make something like this. I could probably think of 10 ways to do it, and so could you, okay? Stryker system is a little bit different. You see, they have this. They're also wire fixation bolts, right? But they can grab any size because it just grabs any size, and it's angled. And you can put it as high as you want it, how low. If it's too low, you turn it into one of these, okay? And what I like is if it's really, really low, oh yeah. If it's really, really low, you use my favorites, these. And you know what's good with these? I could put it on one of these, and I could put it at any angle I want, so it can be angled, you see? So there's different ways to do things. What else is there? There might be some other stuff. I don't want to get into some of the stuff that's totally, like I have a turnbuckle in here because there was an application that I was building something where I went to Home Depot and I used these.
What is that for?
I'm not telling you. Here's a pediatric wire fixation bolt. Remember I said there's really old ones? Pediatric, very, very small. Now I was doing something called the Weber wire technique.
Trying to grab it.
Here's
I need that.
super small, look at that, pediatric sizes. But they're not really used, all right? But they are cute though, you see? Okay. It's like a baby version.
Okay, what are these? Same like circular
Okay.
retro group.
When you're getting into advanced Lizarov stuff, then there's this thing. What the heck? I don't know what this is. It's called a bushing though. I know what it's called. And look, but it has a threaded hole on the end. Okay? Where I could tighten it. What are these used for? Well, sometimes I need something that can do this. But how do I control that? Well, I put a nut on this side and I put a nut on this side. Then when I turn this nut, I can make the whole thing move, okay? So, but this is for more advanced Lizarov. This is not something you're gonna use in a regular frame, okay? And not all companies have them. Do you guys have bushings? No. So it's, I don't know who has them anymore. But if I'm putting on if I'm doing a deformity correction, I want these because I need these for something. But if I didn't have them, I'd use something else. Remember, this also has a smooth thing, so I can make this work also. Okay? Anyway, that's all the parts.
Smooth.